Hello. I'm Merve and I work in this emoji company. And if you stay until the end of the talk, I will give you a lot of stickers. So basically, I work on zero-shot computer vision, multimodal AI. How many of you actually know the term multimodal AI? Can I? That's good. That's good. So for those who don't know what multimodal AI is, it's basically when you have two or more modalities. And when I say modality, it's like image is a modality, text is a modality, audio is a modality, and multimodal in general is when you have an image input and text input or like an audio input to the model at the same time. So initial multimodal models were, you can consider GPT-4o, for instance, was introduced as a multimodal model because it was able to take in documents, images, text at the same time. And now all models can do that, that are available with closed model providers. But the focus of this talk is open source, because I work in an open source platform for machine learning. So what are the use cases for multimodal computer vision? I work specifically on multimodal computer vision. So first one is general vision language models. And vision language model is when the model can understand image and text and output image and text. And then there is multimodal retrieval. How many of you know retrieval augmented generation, RAG? That's good. That's good. By the end of this talk, you will learn that you shouldn't be doing it with PDF parsers and stuff. And the last one is a model type we call any-to-any. And any-to-any is when you have image text audio inputs and image text audio outputs. So very generalistic models that reminds us of AGI. And for open source alternatives to the vision language models, there is Llama 4, released by Meta. There is Gemma 3 by Google that was recently released as well. We have released that Hugging Face small VLM2, which is a self-explanatory, a very small vision language model that can take image and video inputs as well as text and output text. It comes in very small sizes. And there is QVAN 2.5 VL. QVAN is a laboratory at Alibaba which releases state-of-the-art open source models that are super capable. And their vision language model is called QVAN 2.5 VL. And then for multimodal retrieval, which I will explain later if you don't know, but if you know, there is called Poly, called QVAN, DSE models. And for any-to-any, there is QVAN 2.5 Omni model by Alibaba. But why does open source matter, you might ask? So firstly, you can build apps locally and deploy them locally, like on the phone or on the browser. So there's utmost privacy for the user. And you can customize the model according to your use case. You have absolute control over the fine-tuning process of the model. You can quantize the model according to your need as well. And also the model doesn't change because it's basically deployed on your own server. So you do not have to, you do not, when the model changes, you know it because you did it, not someone else. So it will not break your system. And we used to go for bigger and more capable models, but these days we just want to go smaller and more capable. So basically in this graph, if you don't know, LM Arena is a sort of like a leaderboard where you are comparing models. So basically two model outputs are brought to you, and you do not know which output belongs to which model, and you pick the models, the model outputs that is the best. So it's like a arena of human preferences scored by a lot of people. And this graph is on the y-axis, you see LM Arena score, and on the x-axis, you see the cost to serve the model. And we want to go up and left. We want least costful model to be most preferred by humans. So basically, Llama 4 Maverick is the best model as of now. There might be different models because every day there is a new model really also released by community that is improved. And then there is below, way below, there is Gemini 2.5 Flash. You have other models like DeepSeek. So yeah, like DeepSeek R1, which broke the world at some point. So going back, so these were for LLMs, but for the VLMs, this is pretty much the same graph as of now. And for vision language models, what are the use cases? How can you use them? You can use them for document AI. First and foremost, it's a very common use case. You can do multimodal RAG, which I'm going to explain later. Do not be scared. You can do document retrieval. You can have visual assistants, chatbots deployed in phone apps. You can have computer agents. If you have played with, for instance, cloud computer use was most popular use, and the computer agents often operate over the screenshot, so it knows where to click and stuff, which means it requires vision, it requires image understanding, and there is embodied agents, aka robots, which are currently being developed as well, and they are called vision language action models because you have vision and language input, like an instruction to the model, and the robot has the vision, and it does the action that you want it to do. But how did it all start? So with the open source and in general. So first and best used model was Clip by OpenAI, and Clip is basically a model that can understand image and text and sort of connect two modalities. It was the first model to do that. How it works for the machine learning practitioners, let me explain a bit. It encodes the text and it encodes the image, and then it's trained contrastively in the sense that you are trying to push away the least similar images and text and match the most similar images and text. And I think the most popular use case for this is when you type in your iPhone, I don't know if it exists in Android, but in your phone gallery about something, like, I don't know, um, uh, a, 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 a conference, you will get the images of a conference. So it actually runs locally. And this model is actually like, that model is probably small as well, and it works very well. So that is the most similar use case, I guess. But Clip is used in many other places, like in image generation pipelines and now vision language models. I will explain why I'm explaining this later. You might, yeah. So the second one is Siglip2. Siglip2 is basically a better version of Clip, and it's open source. It was released by Google this year, April 2025. It's the state of the art. But the other day, Meta released another model called Perception Encoder, and it's apparently even better than Siglip2. So for instance, if you want to use it right away out of the box instead of doing a lot of image similarity, you can input this image and you give like bunch of labels to predict. There is bee on a flower, bee in the hive, bee in the sky, and it will give scores to each of the labels, saying, hey, this is the most likely the bee on a flower and not bee in a hive. So it does zero-shot image classification. And coming to actual vision language models that everyone is probably using on a daily basis. So you can do a lot of things with vision language models. You can do object localization. You can do even image segmentation. Like over there, the cats are segmented. So you can even do segmentation. And the thing is, normally, like, we used to train models to do image segmentation, but now you can predict segments with open-ended labels. You can say the cat that sits on the net, and it will still predict, because the text is encoded. Like, it's just like in the clip, the text is encoded and the segment is encoded, so like they are sort of matched. You can ask questions about the image, about documents, and so on. Yeah, like possibilities are endless. And the clip model was, clip-like models are used in this type of models. So the first model that was successful and reproducible and open source was called Lava. And Lava model basically takes in a vision encoder, just like the one in the clip, and then LLM, and connects them using a projection layer for the machine learning practitioners. And to do that, basically during the pre-training phase, it freezes the image encoder and text decoder, and only trains the multimodal projector, so it kind of understands how the text is related to the image. And then during the instruction fine-tuning, you freeze the image encoder only, and then train the projector and the text decoder, aka LLM part, and train them on text instructions and images. And most popular, this was the most popular model because it's super easy. Like you just take two models and train the linear layer and then fine tune it instead of training a whole big model yourself. And it was later adapted to a mixture of experts, and there are many other architectures coming up. So there's 4 type of vision language models. This was a bit technical. If you didn't understand, it's perfectly all right. I will go a bit less technical. So there's 4 types of vision language models. So when I was presenting this slide last year, there was only 3 type of vision language models, and there is a 4th one added. First one is the base models. Base models are just pre-trained models. So this part, can you see? So this part only. And there is instruction and chat fine-tuned models, which are trained using this part after this part is done, like this part. So base models. And then chat and instruction models are base models fine-tuned on chat and instruction data. And there is reasoning ones, which is huge now. Base models fine-tuned on reasoning for complex problems. And they actually work very well. I am very excited about them. So I'm going to show you a few vision language models that are open source or open that I think worth looking at. First one is Q12VL. It can do anything. It can do long video understanding. It can do OCR, function calling. It can interact with the UIs, document understanding. Any multimodal use case that you need, it can do. And it's multilingual. It's huge because the thing is, most of the model providers are only training on English, but Q12VL understands a huge variety of languages. And the newer version is Q12.5VL, and it comes in like 5 sizes, I think, like 3B, 7B, 72B. I think they recently released a 38B one, and it can do reasoning, math, OCR, long video understanding, some agentic capabilities, and it is the best open instruct model, basically. And for the reasoning, so basically the reasoning models weren't working. There weren't a lot of them anyway. But now there is a new gamer in the play, and it's KimiVL thinking. I really love this model. It is a relatively small model that can do very good reasoning. I have tested it. And it has Apache 2.0 license, which means it's completely open source. You can use it, like it allows the commercial use cases. It can do many things, just like Q1 2.5 VL, but on top of it, it can do reasoning. And coming to multimodal RAG that I was talking about so much. So normally, how do you do your RAG pipelines? Do you use, like, how many people in here have used like a PDF parser, OCR to render their documents? Can I see? Docling, okay. So there's a better way, in my opinion, and I'm a bit opinionated. So normally you do this, but the issue is it's very, like, if you have a lot of stuff like infographics, charts, images in your documents, tables, it's very hard to do this because this pipeline is firstly brittle, and secondly it requires more compute than it should. And then you give it to a retrieval model, like you render the complete documents. You use an image captioner to caption the images. You use a table to render the documents. God knows what else you use. And then you have complete text and you give it to a retrieval model and the re-ranker model and get the most relevant text. And then you give it to your LLM to get along with the question to get the answer. But please try it my way. So there's another way of doing this. So you have the document here. You give it to multimodal retriever models. These models can take an image, like documents, and text, like a stack of images. And it takes in a question, and it returns you the most relevant document. And then you get the documents. You give this to a vision language model of your choice, and then you get the generated text. So you completely operate in image. You do not parse anything because you do not need to do that. The page that is returned to you is already a page, not a sentence or whatever. And it works very well. And it's not brittle, and it's fast. And moving on, there is like bunch of models, and I'm going to give my candid opinion. So there is multi-vector models. This is state of the art, but it's not memory efficient. And vector databases, as of now, are implementing them. Like it's currently in implementation efficiently, but it will take time a little. The second one is single vector models. It's called DSC. They are only few points behind in benchmarks, but they are very memory efficient. You can make them even more memory efficient if you wanted to. And then there is re-rankers, which are separate from above two. And re-rankers are basically refining the outputs of the above models, the retriever models. So, moving on with some of the open source libraries and services that can be useful for you if you want to deploy and work with open source models yourself. So your usual workflow is you go to Hugging Face Hub and find the model that you need, and you customize it if necessary, i.e. you fine-tune the model, you quantize the model, and then you deploy the model. And to find the vision language models, you go to Hugging Face Hub, you look for, on the left-hand side, image text to text. This is the current way we call vision language models, and you can pick one of more than 8,000 models. I think it will increase by time even more. And you can actually test the models using a new service we have called inference providers. Basically, in every model repository, in here we have a widget for you to test these models right away. And we work with, like, let me zoom in. Basically, we have agreements, partnerships with other inference providers that you might be using, like Together, Fireworks, and Nebius, like all the other ones. And you can test them right away without additional cost incurred from us. Yeah. So for instance, here I do inference on an image with Llama 4. And also, if you do not want to use like widget directly, you can use it through Python, JavaScript, curl. We have a Python clients library that you can use to infer with these models. And now I will talk about all the open source libraries we have. So first one is text generation inference. It is a library you can use to deploy large language models and vision language models. Basically, you have basically this library has a lot of images, like custom images, to have optimized inference. Like it supports stuff like flash attention, page attention, to serve large models, and it also has multi-GPU support, however you want. It can do it also has support for continuous batching, so you can have increased throughput. It has support for different decoding techniques. It can do token streaming and different quantization supports. And this is how you get started with it. It's very easy to get started running a model locally, but you can go to the documentation if you're interested. And for model fine-tuning and quantization, first library, how many of you have used transformers here? I'm curious. That's good. Transformers, if you don't know, is basically a library to work with large models. I mean, also small models across different tasks, but today our case is large, relatively large models. And normally, when you want to test a pre-trained model released by some laboratory, you would have to go through the code base, but it's not the case with Transformers. Transformers provides an unified API to just try the models and fine-tune the models and other things. And it has some very easy to use APIs that I'm going to show. But basically, it has inference support, quantization support, fine-tuning support for different models. You can initialize very powerful models with only few lines of code. So we have an API called Multimodal and Autoprocessor, which initializes the model for you right away. And because the thing is, once you get used to transformers, you do not have to learn how to infer with every single model because this is a unified API. You just infer with the models the same way all the time. Even if a new model comes, it is loaded into the same class and has the same API. So you do not have to go through the code base of any model, basically. So this is how you initialize Qwen2VL. And then the thing is, these large language models and vision language models, if you have played with the open source ones, you might have seen it has stuff like tokens and special tokens like end of sentence token, beginning of sentence token, image tokens. You do not have to deal with them yourself when you use transformers. We have something called chat template. Let me zoom in because some people are taking the image of the place. So basically, you give the chat template, like how you would do with other model providers and such. And then you apply chat templates using the processor, and then you process the inputs, the process text, like the chat templated text, and along with images, and then you just pass it to the model. You just infer. You call model.generate, and then you decode and you get the output. So it's with few lines of code, but even like this gives you a lot of control still. You can load the model with the stuff like flash attention, for instance. But if you do not want any of this, I'm going to show you another API. So now that we've seen it, if you want to load the model in quantized way, for instance, bits and bytes is a quantization library. You can use, for instance, bits and bytes config. Sorry. And then just with few lines of code change, perhaps 1-2 lines of code change, you can just load the model in quantized way, in 8-bit specifically here. And then if you don't want to deal with any of the model loading, generation, decoding, and all the other stuff, you can use pipeline. So pipeline basically encapsulates all of the process. Think of it as a box that has the model and the processor. You just pass the input, get the output. That's it. And few more libraries. We have time anyway. Parameter efficient fine-tuning PEFT is a library you can use to apply LoRa, low rank adaptation. Like it's like a parameter efficient way of fine-tuning. If you haven't heard of it, don't worry. You can check the documentation later on. But it allows you to fine-tune models without fine-tuning the whole model. And it's more efficient way to customize models. And for those who know, it has supports to LoRa, QLoRa, and other parameter efficient techniques like LoftQ and so on. Another library is transformers reinforcement learning. So basically, if you have heard this whole reinforcement learning with human feedback and other things that made the AI revolution so big revolution with ChatGPT and stuff. So those are called alignment techniques. Basically, a model that is pre-trained is insanely uncontrollable, but you can align the model to talk with humans, being helpful, etc., using reinforcement learning. And transformers reinforcement learning is a library to do this. It has easy alignment techniques for vision language models, as well as many alignment techniques for LLMs, and you can also apply LoRa and QLoRa. So, and how you just initialize so basically this class called SFT trainer is supervised fine-tuning trainer. It's a class to fine-tune. This is direct preference optimization trainer. So you just initialize these classes, write your pre-processing code, and just call trainer.train, and then if you want to push your model and share it, trainer.push to hub. And coming to latest library, small agents is my favorite these days because I'm also working on it. So small agents is a very lightweight library to start working on agentic workflows with local models, remote models, and it also has support to multimodal agents, which we have implemented recently. And multimodal agentic use cases include multimodal RAG, automated web browser, computer use, which we are currently working on right now, the GUI agents with Vision LMs. But as of now, you can do automated web browser, for instance, with small agents. So for instance, in here, I start this web agent command is just a CLI command to get started with the web browser, automated web browser. So in here, I tell the agent, please go to the asos.com and then get the first item for me, return the price. And this is completely run with a vision language model, and it doesn't go to HTML parsing and stuff. So it does what it sees and it picks what it thinks that is appropriate, like the cookie acceptance, I don't know where you are shopping from, etc. It handles it. Pretty cool. And if you want to see the API a little, let me show you. So small agents has support to different model types. There is transformers model, which is about local transformers models, the transformers library. For instance, you can load Q12 VL72B instruct like this, but it also has support to remote models, different model providers, and so on. If you want to use GPT-4o, you can do that. If you want to use I don't know, like remote served Llama 4, you can do that. And then you can initialize the class code agent. So there is different types of agents. There is tool calling agent. There is code agent. Code agent is basically a agent that can write its own code. So it's a recent paradigm that models are outputting the code that it has to run to complete a task. And code agent does that. And then you call agent.run, like if you want to describe images, if you want to, whatever you want to do. But if you want something like web browser, for instance, you can do like at the end of every step, like a thinking step, you can call save screenshot and then pass it along with some tools, go back, close pop-ups, search item, control F. You can pass this to be run at the end of every turn, step callbacks, and you can initialize your agent like that and then run. So it provides a very nice API to work with agentic workflows. And this is my project, Small Vision. Small Vision is about fine-tuning models, quantizing vision models, working with them, multimodal RAG, like everything that you can find that you want to do with vision language models. There is a notebook, a script, and tool for doing that in Small Vision. So please check it out if you enjoyed this talk. And I can have your questions now, I think. Thank you.
We have bum, 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 bum. Oh, we have some questions. Okay, very easy one. Does the presentation will be shared for open source model? Maybe. You can ask nicely. Okay, can you talk more about re-rankers, how they are trained?
Re-rankers.
Yeah.
I think as of now, there is only one re-ranker because it's a very recent thing, but retrievers are more prominent these days. So what do they do is that I have to show
Makes sense.
Kolpali architecture. So it's a bit more complicated. Bear with me. Open image in new tab. Yeah. So this is basically what you used to do. Here you have the image. You go through OCR. You do layout detection. You chunk them. You pass it to the text embedding model, and then you get the similarity with the text query. So this is the text query. What are vision transformers is a question, and then you have this max similarity function, and it gives you the most similar text part along with the similarity score. But for Kolpali, it's completely different. Kolpali is in my opinion, first most successful multimodal retriever. So what it does is that it cuts the images into pages and then pass it to the image vision. So basically pass it to your VLM. So this alone is actually VLM, which is very interesting. And then gets the output with a projection layer. And then again, there is an LLM here that encodes sort of the input. And then there is another max similarity happening here. So this is how Colpali actually is. But if you're interested in how they are trained, basically they generate the similarity scores using a big LLM. Like you have a question and you have some documents, and then you pass it to, I don't know, GPT-4o or Gemini. People use Gemini for that because, I don't know, they found it to be better. And then Gemini provides the most similar documents, and basically they make a data set out of it. And basically they train this model using that data set.
Okay. Thank you so much. Okay, so the next question I have to show you, it would be easier. So how do you recommend running your Hugging Face models at edge on the phones? Onyx plus JavaScript, GUF, Llama Cap, and Candle plus
Good
WebAssembly.
question. I mean, it depends on your use case, in my opinion. I'm not a fan of ONNX. If you have actually worked with ONNX, you know how brittle it is at times. I do not believe in one format fits all type of file formats ever. Most people use GGUF and Llama CPP. I think if the model is implemented with Llama CPP, you can do that because it gets you easily started. But if the model isn't implemented, what are you gonna do? I mean, it's hard. I think it really depends on your use case.
Okay.
There was also on the next JavaScript. Instead of doing that, use transformers JS. Let me find. So this is a library that my friend is working on. It's a JavaScript library where the models are already like ported to transformers to JavaScript, and it's very nice. So I would suggest it. It depends on your own use case and runtime. It's not which one should I pick type of thing.
Okay, we have plenty of questions coming in,
Okay.
so bear with me. Christianis is asking, with multimodal models becoming lighter and lighter, do you think portable AI devices like the Rabbit or One or human AI pin would become commonplace? Can you imagine people adopting them and using them to make everyday decisions?
Yes. Yes.
That's the answer.
So basically, small VLM2 with, for instance, small VLM2. One of my colleagues two of my colleagues have built a iPhone app, and it is like on locally you can just take a photo and ask questions. It's a bit small though, so like it comes in 3 sizes: 256 million parameters, 500 parameters, and 2.2 billion parameters. The one that was for 256 million parameters was deployed on iPhone like that. It's a bit insane when you think about it, but in my opinion, this is like a good first ever local vision language model. But it will be even better when models get more capable and less memory hungry, basically. For sure, for sure. I was saying it all the time that we have to always go for smaller and more capable models, and it started happening. Now we will have the same with vision language models.
We still have time, so you can ask the questions in the Discord, and I will be the voice for you. So a bit lighter question.
Okay.
Why are we developing things which will make us unemployed?
In my opinion, the thing is, I believe that with every industrial revolution, there has been some job changes. People are not doing heavy labor anymore. And for the things that we can automate, I think we should automate. I think it's actually my dream to automate all the bureaucracy. Like imagine all the bureaucracy being automated. Wouldn't you like that?
That's true.
I don't, to be frank, I don't like the fact that like art and creative stuff are done with AI. I think humans should do arts and crafts and other cool things and not boring things, but also people are currently doing
And to do my laundry as
art.
well, so that would be
Yeah,
nice.
like I think we should have more embodied agents and save time and cost and stuff.
Yeah, to do the dishes and laundry
For,
would be
for,
nice.
for coding, I think code like the job of a developer is way harder than coding itself. So I don't think it will replace developers. No.
Next question. What about image text to image? Which providers models are leading that?
I think I have shown in my presentation
Mhm.
already
Yeah,
the ones that
just
I
a
think
reminder,
are
maybe, yeah.
yeah, I think the ones that are worth looking at are these ones as of now.
Okay, next question. How soon until 2024 GPT-4 level models can run on laptop or phone?
I have no idea. I have no idea, but the thing is this I think I showed here llama. I'm not sure like this is a good graph because it like with the more you go on left you have the smaller and more cost efficient models when you think about it, and llama is already very up over there compared to like Gemini and O3 mini and so on.
Okay, great. What can I use to keep up with all new model releases?
To be frank, I use multiple things. I mean, I work at Hugging Face, so for me it's easier. But
You can work at Hugging Face as
yeah,
well.
just work at Hugging Face. So this models page, when you go hf.co/models, the models are ranked according to the algorithm. That like the more used they are, the more downloaded, more likes they have, more discussions they have, etc. So like if a model is very making a lot of noise, there is very little chance that you are going to miss out if you just visit this page. Also, I think people were saying they were using docklink. So basically with IBM, we have collaborated, I wanted to mention, we have collaborated to train small VLM models with docklink format, and we came up with small docklink. And it's a very small yet very capable document parsing model if you still want to use document parsing, of course.
There's a follow-up question. How
Yeah.
about text to video? Which providers models are leading?
I don't I that's not my expertise, but I have seen a lot of them. But you should visit Hugging Face Hub, and there is another one. There should be a tag in here for text to video. Yes, here actually, here text to video. Go to text to video, and first few models will give you high signal. There's a lot of tasks here like text to image, image to text, image to video, and so on. So it's not only limited to vision language models or large language models.
Okay. Okay, Eustace is asking, I have only used Olama to run models on my computer, but I have noticed you have used a different tool. What tool do you prefer to use for local LLM hosting and why?
Honestly, I think so. I have shown you text generation inference here. I think Ollama gives a good interface for everyone to get started, and that's what made it so revolutionary, in my opinion. For text generation inference, so basically, I think you can use Ollama with Hugging Face models right away. You just give the model ID, and you will get started right away. I don't have a strong preference. Reason why I'm showing text generation inference is that like it's very good, and I think it has the best vision language modeling support. That's why I'm showing text generation inference, but it's also developed by Hugging Face, and that's also why I'm showing it.
Oh, makes sense. Mindogas is asking, how do you see quantum compute impacting AI development? Would it help to accelerate progress of models?
I'm clueless. I'm just a developer. Please ask me.
We can ask each other as well. Arvidas is asking, how safe is it to download the model from Hugging Face? Can someone implement a malware to post it for people to download the model?
Yes, pickle is not safe. And PyTorch model format is also not safe. It can have custom functions inside. Do not use them. So basically, we have our own model format called safe tensors. And in Hugging Face repositories, most of the models are safe tensors files. So when you download them, you download safe tensors. So text generation inference also supports safe tensors. And I think many libraries now have adopted safe tensors. You should use that and not PyTorch models directly, or pickles. Not even like scikit-learn also use pickles. Do not use that.
Okay, anonymous question, I would say. Can web browsing multimodal agents be blocked from a site? If so, how can one bypass it asking for a friend?
That's actually very hard. Like it really depends on what the website is implementing. Most of the time it's easy to pass, but I think for reCAPTCHA and stuff, I'm clueless about like what the models will do. I actually wanted to test it recently. I think I'm gonna do that, and I'm gonna post it somewhere.
So stay tuned.
But feel free to also test yourself using small agents, new agents library.
Okay, so is still typing, so I'm just waiting. Where's the question? Any questions from the audience? You maybe want to raise a hand.
I think we have 9 minutes at
Yeah,
first.
and there's the break
There is
afterwards.
one.
Oh, go ahead. Yeah.
Yeah. That was good.
Yeah.
Yeah, I mean, it's very cool. And also the thing is, you can, if you're a coder, you can just go through it and just, if it doesn't suit your use case, if you want to hack it, you can just hack it. Like, I find it pretty cool. I'm really with the one with the open source. So yeah, like, I completely agree.
Okay, there were some hand here. Go ahead.
Not at all. I mean, I work on a workstation with 800s inside with 8 gig VRAM. So I'm not GPU rich, but I'm a GPU middle class. But this is very GPU poor if you want to work on it.
Yeah, any questions from the audience? Raising a hand? Go ahead.
Yeah. So basically, yes. The thing is, so basically, Small Agents implements a framework called React Framework. Let me open this in another tab. So basically, normally it's very hard to debug agents because it has a lot of reasoning steps, and you have to go through the reasoning steps in order to see where the model glitched. And also, like, if it takes screenshot, if it wants to click somewhere and it fails to click, you need to figure out why it fails to click. Is it because also agents involve a lot of tools? Like, for instance, for web agent, we used a tool called Helium. I don't know if you have heard of it, but it's basically to control a browser and click stuff. For instance, it can glitch at Helium and other tools. But a typical agentic workflow consists of React framework, and React framework is basically about you get an input, a query, an image. You can get also images repetitively, like with screenshots, and you get the thought. You give the you execute stuff with the tool, and then you get the output. It goes back if it thinks that it couldn't find the answer just there. So you can actually put breakpoints in the steps of the agent framework to see, but it's actually harder to debug, obviously, to compare to regular programs. So.
Okay, thank you so much. 2 more questions. Go ahead.
Inference providers. The thing is, these are model providers. Model providers don't train models, they just serve them, all of them. Like, none of them train models, like Fireworks together. They don't do that. And that's pretty okay. If it answers your question. But if you want utmost privacy, serve your own models. Do not do this.
Okay, there was a hand. Please, go ahead.
Yes. Yeah. Hugging
Secret
Face
ad.
has agent scores.
Secret ad coming from the audience.
Yeah.
Okay, go ahead there. Yeah.
I mean, technically, when you would you give me a second, call poly, or let me type DSE. No, I don't get multimodal retrieval. The thing is, or let me type vision transformers. So basically, at the very core of this technology, there is vision transformer, and vision transformer is part of the vision language models. Vision transformer essentially divides the image into patches and encodes those patches using a linear projection, and then the transformer encoder, which is essentially a compressed embedding. So technically, this is one of the best compression methods when you think about it, that still preserves the semantic understanding of that image. So essentially, and then this is used for instance, this architecture is for image classification, and then you get that embedding and pass it to the head. Head is the part that does classification, and then you get the class, like if it's a bird, a car, whatever. So technically, this is a compression that is efficient and good at the same time. Does this answer your question? Okay. Thank you so much.
Be patient. Okay, any questions from the audience? We have 2 more in the Discord. Okay, let's go here then. At Hugging Face, you
minutes.
develop Candle for running saved tensors in WebAssembly. Can you talk more about it?
I'm clueless. I'm sorry. I don't know
It's
much
not a
about
person.
Candle really, but we do have it. Yeah, we do have people working on Rust and other cool stuff that do that.
So Merve can connect you. So if you have, okay, isn't Vision Web Agent much more expensive than HTML parsing? I believe combination of both should be used.
Good question. It's more like so basically when you are, as a human, when you look at the website, how do you decide on like what to do on a website, what you want to do on a website? Like, you just look and click, right? So like even if the things change on the website, you can just still look and decide on what you want to do. So basically, with the former web automation frameworks, they were memorizing layouts in a way, and hard coding things according to layouts or HTML behind it and deciding on what to do based on the memorized HTML. So it's actually better to decide when the model just looks for once and just guesses what to do and just does whatever you want it to do, in my opinion. Because this is a website is an image, and like it's always better to go with the image, not to have brittle workflows. But that's my opinion.
Okay.
Yeah. It scrolls like with yeah, that you can say that, but the thing is, it by default it scrolls the page to look for it, and I think that's not much to do. You can even do batch inference if you want to. Like you can take the screenshots, like I don't know, four screenshots, do batch inference, and get the answer that you need if you wanted to. As of now, I don't think it makes a lot of sense, but later on, why not?
Okay, thank you so much. Final questions.
Time's up. Yeah. Captchas, yeah. Someone asked it before about robots and stuff. Yeah, and I said that I haven't tested. I should test. I haven't tested. But for cookie pages and stuff, like where you are shopping, it just passes them well, but I didn't guess. I didn't test with the captchas yet.
So Merve should come to PyCon 2026 and you can ask the same question there as well. Okay, any final questions? No more questions, so give a warm applause to
Thank you.
Merve.